Hello. All right. Last section, Math 268. And we're still dealing with chapter 8, two variable functions. And now we're going to do derivatives. And so we're going to review derivatives a little bit since it's been a minute since we've done them. So here we go. As always, ask me questions if you have them. Okay. All right. So let me get set up here. So from Math 267, let's go through some of our derivative rules, and we'll get back to these. Okay, they're going to be the same rules. It's just that, remember, sometimes x will be a constant or y will be a constant, but we'll talk about that in a minute. Let's just talk about the derivative rules. And I emphasize the word constant, and that means number, but it's a constant term. All right, so rule number 1, the 3 basic rules. If f of x is a constant, a number, what's the derivative? It's 0, okay? All right, and then the second rule is if f of x is a constant times x, 5x, 3x, 2x, 1/2 x. So if the function is a constant times x, the derivative is just a constant. That doesn't look like a good C. But we've done some of that. We've done some derivatives. With u substitution, we did derivatives. We picked u and found du. With integration by parts, we u and du. Du is the derivative of u. And 3, if f of x is x to any power other than 1, then the derivative, what do? We multiply down and we subtracted an exponent. Okay, so those are your 3 basic derivative rules. Okay, all right. So a constant, the derivative of a constant is 0, derivative of a constant times x. So if we have the function x squared plus 3x plus 2, we're going to use all of the rules. This is rule 3. You multiply down and subtract an exponent. The derivative, the rule 2, a constant times x is 3, and the derivative of a constant 2 is 0. Okay, so that's using all the rules. That's great. We know how to do it. Perfect. Okay. One thing that we learned in 267 that we didn't talk about a lot, okay, is a constant times a function rule. We talked about it, but then we didn't use it a lot. This is what I'm talking about. So look, if y is equal to x to the 4th, rule 3 tells us y prime is what? You multiply down and you subtract 1, right? That's not a problem. Okay, so the constant times a function rule, if y is 5x to the 4th, okay? So what we learned that we never do in 267 was the constant times a function rule is the derivative is 5 times the derivative of the variable term, 4x cubed. So the derivative was 20x cubed, right? Well, yes, but we didn't go through this step, right? We just went, boom, 5 times 4 is 20, minus 1, right? And we got right to here. But now we're probably going to, just like in 268, we use this a lot, right? We bring the constant along and we just deal with the variable term. We're going to do that some in 267 now. But that's, so I'll write this as a sub-rule 3. So if f of x is a constant times x to a power, then the derivative is we bring along the constant and then we just take the derivative of the variable term. Okay, so we'll use that a good bit. All right, so those are your 3 basic rules. So remember in 268, in chapter 8, a constant could be a y or an x. So we just, if I have a constant times a variable to the first power, the derivative is the constant. If I have a constant term, the derivative is 0. if I have a constant times the variable term, I bring the constant along and take the derivative of the variable term. So basically that's what we're going to do with our derivatives, okay? But we're going to go and review some derivative rules that, more derivative rules that we're going to use in 8.2, derivative rules. Okay, so if y is a constant times a function to a power, if I have a quantity to a power, then y prime is, we bring along the constant term and we multiply down times the inside minus 1, and then we multiply it by the derivative of the inside. We talked a little bit about this on test 1 because substitution is undoing this rule, which is the chain rule, right? So a real life example of that would be if y is 5 times 3x squared plus 1 to the 4th power, right? So y prime, if we have a quantity to a power, we multiply down times the inside minus 1 times the derivative of the inside. And we don't have to simplify. So that's the chain rule. So we're going to talk about the chain rule, derivatives, the derivatives of e's and ln's, okay? So if y is equal to the ln of a function, okay? All right, we talked a little bit about this in 7.1 when we let u be the ln, but y prime is, if you have the ln of a function, the derivative is the derivative of your function over your function, okay? All right, so an example of that, so what if we have 5 times the ln of 4x cubed plus 2x plus 1, okay? All right, well, since 5 is a constant, we just bring it along, okay? And then my rule says if I have an ln of a function, it's the derivative of my function over my function. And that's it. We want to just leave it alone. We want to do as little simplification as we possibly can, because the more we do, the more we can mess up, okay? All right, so one more. Let's talk about the exponential rule. Okay, and so I believe these will be all the rules that we need. All right, for our 268. This is just still 267 review. And if y is a constant times e to the power, okay, and we've integrated e to a power, we divide by c e to the kx, we c e to the kx divided by k, but remember this is the derivative. Y prime is the constant times e to the power times the derivative of the power, okay? All right, so a real live example of that would be, so if y is 5e to the 2x squared plus 1, okay? So my derivative is that constant 5e to the 2x squared plus 1. The exponent on e never changes whether you differentiate or integrate. You never subtract 1, you never add 1. It stays the same, but you have to remember to multiply it by the derivative of the power, okay? So the derivative of the power, and we can leave it just like that. Okay, so that's our derivative rule. So I'm hopeful that those mean a lot. I mean, those, you remember those, right? Okay, all right, well, we'll come back to our rules, okay? All right, but let's talk about partial derivatives. In 8.2, they're called partial derivatives. Okay, so if I have a 2-variable function, okay, then so if f of x is a two-variable function. Then it has two first derivatives. It's the derivative of f of x, y, I'm sorry, f of x, y. We can take the derivative with respect to x. Okay, and so we'll talk about notation a little bit. So the derivative with respect to x would be the derivative of f with respect to x. Okay, that's just a funky notation that you use. Or they use the derivative with respect to x of xy, or they use the derivative with respect to x. So that's how you know what variable you're using with respect to, because what happens if we take the derivative with respect to x? If we take the derivative with respect to x, then x is our variable term, and y is a constant. So we dealt with this a little bit in 8.6, okay? All right, so every function has two first derivatives, and they're going to ask you for both of them, okay? So if we take the derivative with respect to x, they'll say the derivative of f with respect to x, or the derivative of f of xy, or the derivative with respect to x. You'll see on the homework, the notation, I haven't ever had people go, oh, I can't do this because of the notation. It's okay. But if you take the derivative of f of xy with respect to y, the notation, I should have written that there. Because, you know, for derivatives, they had different notation, f prime of x, y prime, dy over dx. That would be more like that. The notation is going to be the derivative of f with respect to y. That's a change in f with respect to y. Okay, it's like a delta. All right. Or they'll say the derivative of xy with respect to y. The little y will be right here, the little x, or my favorite notation, because it takes so less time, is the derivative with respect to y. Okay, and what happens if we're going to take the derivative with respect to y? What does that mean? That means what? Y is the variable term, and x is a constant. Okay, so we're going to use a whole lot that a constant times a function rule that I was talking about. Okay, so if I have a constant times a function, I'm going to bring the constant along and take the derivative of the variable term. Okay, so another example before we get into the two variables, if I have 7x to the fourth, right? The derivative, my new way to take a derivative is to say, okay, I'm going to bring my constant term along, and I'm going to take the derivative of the variable term. Okay, that's our new way. Okay, bring along the constant, take the derivative of the variable term. We've been doing that with antiderivatives. Bring along the constant, and then integrate the variable term. So I think you're ready. You ready? We got the notation, the derivative of f with respect to x, the derivative of f of xy with respect to x, the derivative with respect to x. X is variable, y is constant. The derivative with respect to y, notated by the derivative of y with respect, derivative of f with respect to y. F of xy, the derivative with respect to y, the derivative with respect to y. Y is the variable term and x is constant. So y'all got this. Last section. Let's do it. Okay, I wrote down all the homework. So here are all the homework problems. Okay, so here you go. Here are the practice problems. So Here's my two variable function. F of xy is equal to negative 6x minus 17y plus 2. Okay, so the first thing they asked me to do, step 1, is find the derivative of f with respect to x. Okay, all right, so I'm gonna get, while you're writing that down, I'm gonna see if I can find it. Okay. All right, so if I take the derivative with respect to x, right, there's my x. You can't see that very well, but that's my variable term right there, that x, okay? So everything else is constant. So if I'm taking the derivative with respect to x of negative 6x, it's just normal. It's negative 6. And what's the derivative of negative 17y? Remember, if you're taking the derivative with respect to x, y is constant. So what's the derivative of a constant term? And what's the derivative of a constant term? Well, the derivative of a constant term is 0. So this is my derivative. Step 2, they want you to find the derivative of f with respect to y. Okay, so my original function, oops, f of xy was negative 6x minus 17y plus 2. And so what I normally do, if I'm going to take the derivative with respect to y, kind of circle my y term and go, that's my variable term. So this is a constant term, and this is a constant term. So that derivative is 0, this derivative is negative 17, and that derivative is 0. So if I'm taking the derivative with respect to y, y is my variable term, everything else is constant. So these are at first a little easier. I call them standalone terms, like my x term stands here, my y term stands here. There's no xy term multiplied together yet. That's when it gets a little bit, you know, challenging. All right, so that's question 1. And let's look at question 2. And so the first thing for step 1, they ask me the derivative of f with respect to x. And then for step 2, they ask me the derivative of f with respect to y. Okay? All right, so if I'm taking the derivative with respect to x, x is my variable term and y is my constant term. So I'm just going to take the derivative of negative 19x cubed. So I'm using my rule 3. I multiply down. Negative 19 times 3 is negative 57x, and then I subtract 1 squared. And the derivative of negative 12y cubed with respect to x is 0 because that is a constant term, and the derivative of a constant is 0. Okay? All right, I'm going to write down my problem again just because I messed it up. Okay, so now they're asking me the derivative of f with respect to y. That's how I know what, there's my variable term. Okay, so if I take the derivative with respect to y, x is constant. The derivative of a constant term is 0. So the derivative of my y term is just normal. Derivative, I multiply down, negative 36 y squared. That's just your basic rule 3. Okay, your simple power rule. So that's that. Okay. So while you write this one down, I'm going to write it down again just because I'm going to mess this up. So x cubed plus 5x squared y to the 4 plus 2x y cubed plus 19. Okay, so step 1, they asked me to find the derivative of f with respect to x. Okay, so x is my variable term and y is my constant term. So x is my variable term. This is what helps me a whole lot. Okay, so there is my variable term. So remember from my rule, so if I'm taking the derivative with respect to x of just an x term, it's just normal. That's just 3x squared, okay? All right, but now here I go. I have a constant, I have x squared times y to the fourth, okay? If I'm taking the derivative with respect to x, okay, then x is my variable term. 5y to the fourth is constant, and I'm multiplied by the derivative of my x term, okay? Plus, if I'm taking the derivative of just my x, the y term is constant. It's just like a 2. So 2y cubed is my constant term. And what's the derivative of x? It's 1. And you can leave it just like that. Or you can multiply it out. You just have to figure out what you want to do. Okay? It's like light bulb mathematics. It's like when you get it, you get it. Now on step 2, they want me to find the derivative of f with respect to y. Okay, so what I do is I go find my y's, okay? And so if it doesn't have a y in it, this is a constant term, okay? That means the derivative is 0. This 19 is a constant term. The derivative is 0. But here I've got x, y terms multiplied together. So if I'm going to take the derivative with respect to y, it's the constant term, 5x squared, times the derivative of the y term, 4y cubed, plus, here you go, it's that constant term, 2x, times the derivative of the variable term, 3y squared. And you do not have to multiply them out. You certainly can multiply them out, okay? But I think it's easier. I do. So the derivative with respect to y, remember, x is just a constant term, so that derivative is 0. So when I have a constant times y to the fourth, I bring along my constant and take the derivative of my y term. And when I have a constant times y cubed, I bring my constant and take the derivative of my variable term. Okay. All right. So here we go. Okay. So let's look at this one. All right. So the first thing I'm going to do is rewrite this. And the square root can be rewritten as what power? It's 1/2. A lot of people want to write -1/2, but why would you write -1/2? Because you didn't move it up, right? I'm going over here to find my the derivative rules I wrote down so I can show you. Okay. All right. So the first thing I'm going to do is step 1 is I'm going to find the derivative of f. I always ask with respect to x first, okay? All right, so this is my x term. It's underneath that 1/2 power, okay? So let's look at my chain rule, okay? If I have a constant times a quantity to a power, I bring along the constant term, right? And then I take the derivative of the variable term. So it'd be 4 times that cubed times the derivative of the inside, okay? So if I'm taking the derivative with respect to x, y is constant, so it just comes along, okay? Times the derivative of the x term. So the derivative of the x term is going to be the chain rule. So that's going to be times 1/2 11 plus x squared minus 1 times the derivative of the inside. And I'll leave it alone, okay? So if I have an x term times a y term, and I want the derivative with respect to x, this is a constant times a function, right? I bring along the constant and I take the derivative of the function term. And the derivative of the function term was the chain rule. Okay. Now, if Hawks does all this, they'll call that xy cubed over the square root of 11 plus x squared, but you know you don't have to do that, okay? They simplify, you don't have to. This is perfectly fine right here. In fact, I'd rather you'd leave it like that so I can see any partial credit or anything like that. Okay, so I'm gonna write down my function again, just so I can write on it. Okay, so now, same function, step 2, they want to find the derivative of f with respect to y. Okay, so here is my y term. It's the y term times the x term, right? It's a constant times the function. So I'm going to take the derivative of my variable term, and I'm going to leave the x term all alone. Okay, because you don't have, that's just a constant term. It's just an uglier one. I took the derivative of my variable term times the constant term, or you could have left it as 3y squared times the square root of 11 plus x squared. Those are the same. Okay, however you want to do it. All right, so just be careful. Just say, I'm taking the derivative with respect to y. I've got two terms multiplied together. This one is my y term. I take the derivative of it. I multiply it by the x term just like it is. Okay, you've got this. Okay. Now they've started the new notation that I like, my favorite notation. Okay. All right, so let's go back to my derivative rules. And remember, from 267, if y is a constant times e to the power, what did we say? Y prime is the constant times e to the power, and we multiply it by the derivative of the power. Okay? All right. So if I'm taking the derivative with respect to x, 9 is just a constant, and e to the 2x plus 3y remains the same because I'm not, I can't change the exponent on e, but I have to take the derivative of the exponent with respect to x. Okay, so the derivative of 2x plus 3y with respect to x, the derivative of 3y is 0, so the derivative of 2x is just 2. Okay, and if you want to call it 18e to the 2x plus 3y, you can. Either one of these is fine. They're the same, okay? And then let me write the function down again just so it's neater. Okay, and my favorite notation means find the first partial derivative of f with respect to y. Okay, so it's a constant times e to a power. So it's going to be the constant times e to the power. The exponent on e never changes, but we have to multiply it by the derivative of the power with respect to y. So that means 2x is constant, so that derivative is 0, but the derivative of 3y is what? 3. So you can leave it like that, that's fine, or 9 times 3 is 27e to the 2x plus 3y. The exponent on e never changes. Okay, all right, you're doing great. We're halfway there. Okay, LNs. Remember we talked about LNs. And we said that if y is equal to the ln of a function, then the derivative is the derivative of the function over the function. So if y was a constant times the ln of a function, we bring along the constant, and it's the derivative of the function over the function. Y'all, I wish I had a jingle that could say something like low D high, like the quotient rule, or 1D2 plus 2D1, like the product rule. But the derivative of a ln term does not have an ln in it. So if y'all can think of a catchy jingle for me, you can let me know. Okay, ready? Now, for two variable functions. So let's take the derivative with respect to x. Okay, so here is my x term, and here's my y term. So the derivative with respect to x, I take the derivative of the x term, negative 5x, times the y term. Now I keep the ln because the y term is just constant, okay? So I had a variable times a constant. I took the variable derivative of the variable term times the constant term, okay? And then let me write this down again. So, and the only reason it has the ln in it is because I wasn't taking the derivative of the ln term. So here we go. Here's my original problem. And this is what people miss the most, the derivative with respect to y, okay? Okay, so if I take the derivative of this with respect to y, there's my y term, right? I can't separate the ln and the 2y. So it's the constant term, negative 5x, I bring along, times the derivative of the ln term. Well, the derivative of the ln of 2y is just 2 over 2y. And that's it. Okay, the derivative of the ln doesn't have an ln in it. Okay, Hawks will cancel out the 2's and call it negative 5x over y, but you don't have to. You can leave it just like this. That's how I leave it. But Hawks does that. Either is fine, but that's what I do because I like to see things just like they are. Okay, so we've covered a lot. We've covered the derivative rules, chain rule, E rule, exponential derivatives, logarithmic derivatives, and so let's keep going. Okay, so I have an ln. All right, so I'm kind of that step one. They always ask me to take the derivative with respect to x. Okay, one thing I do want to tell you, the derivative of ln, I've already said this, doesn't have an ln in it, but what I would do is make my fraction bar first. Okay, because you can't start typing and then make your fraction bar in Hawks. So it's just the derivative of this with respect to x over this. So I'm going to go ahead and put this on the bottom because it remains the same. It's the derivative with respect to x. So the derivative of 5x to the fourth, that's just normal. It's 20x cubed plus, but here you have a x squared times a y cubed term. So to take the derivative with respect to x, it's the derivative of the x term to x times the y term. And don't start trying to go, oh, I can cancel those, or I can cancel these. Just walk away, okay? These polynomials are connected. You could factor out a 2x, but you don't have to ever factor anything out. It's just the derivative over the function. The derivative, the partial derivative is 20x cubed, and the derivative with respect to x is the derivative of the x term, 2x times the y term, just like it is, okay? I'm going to write the function down again just because I've messed it up a little bit. Okay, and they, step 2, want you to find the derivative with respect to y. Okay, the derivative of an, so it's a ln, right? So it's going to be the derivative over the function. I'd make my fraction bar and put the bottom in first, okay? So the derivative with respect to y, there is my y term. That means 5x to the fourth is constant, so that derivative is 0, okay? And then it's going to be x squared times 3y squared, okay? So it's the constant term times like 3y squared. You bring along the 3 and take the derivative or whatever. So it's when you take the derivative with respect to y, you bring along the constant term and you take the derivative of the variable term. And you can call that 3x squared y squared. It doesn't matter, but I just leave it like that. Okay. All right. Moving forward. No. That was 7. This is 8. Okay. Okay, so that's negative 3x squared e to the y to the fourth minus 3y to the fifth e to the x. And step 1 is going to be find the derivative with respect to x. And then while you write that down, I'll write my function down again. So I can I'll just write my function down again. Okay, so the derivative with respect to x. So when I'm taking the derivative with respect to x, this is me going, okay, this is an x term and this is an x term, right? And so it's the derivative of the x term times the y term, and the y term happens to be in the e. You can't disconnect them, so it's just the derivative of the x term is negative 3, and it's e to the y to the fourth, okay? All right, minus 3y to the fifth, that's my constant term, times the derivative of e to the x, which is e to the x times the derivative of x, which is 1. Okay, you don't have to put the 1. So let's go recap. The derivative with respect to x, the derivative of the x term, negative 3, times the y term, just like it is, minus, I brought along the y term, just like it is, and I took the derivative of the x term. The derivative of e to the x is e to the x times the derivative of x, which is 1. Okay, all right, people usually get that one. It's the derivative with respect to y is Miss Moore. Okay, so let's just recap real quick. It's, if I weren't so messy. Okay, well, all right, so here we go. The derivative with respect to y. So here's my y term, and here's my y term. Okay, all right, so it's going to be, if y is my variable term, it's going to be my constant term times the derivative of e to the y to the fourth with respect to y. So that's e to the y to the fourth times the derivative of y to the fourth, okay, minus 15y to the fourth, the derivative of the y term times the x term. And you can leave it just like that. I mean, Hawks won't leave it, but it's just easier for me. So with respect to y, we bring along the x term because it's constant. And the derivative of e to the y to the fourth is e to the y to the fourth. This is what people forget to do, is you have to take the derivative of the y to the fourth, okay? Minus the derivative of the y term, 15y to the fourth, times the x term, e to the x. Okay? Okay, and this one is exactly like number 8, and there are 2 of them, and I'm just going to do them. Okay, so the derivative with respect to x, and while you write that down, I'll write my function down again so I can have a fresh function to take the derivative with respect to y. Okay, all right, so the derivative with respect to x, I've just got one term plus one term. So the derivative with respect to x, there's my x, and here's my x. The x is attached to the e, so you can't unattach them. So the derivative of my x term is minus 6x squared times my y term plus 2y, the constant term, times the derivative of e to the x squared, which is e to the x squared times 2x. And I just leave it just like it is. Okay. All right, now the derivative with respect to y. Okay, so here's my y term, and here's my y term. Okay, so it's going to be the constant, negative 2x cubed, times the derivative of e to the y, which is e to the y times the derivative of y, which is 1. Of course, you don't have to put that, but I just wanted to show you that was the derivative of y. Plus the derivative of 2y is 2 times the x term, which is constant, e to the x squared. Okay, those methods work for me. I'm very visual. Got to draw circles around, you know, I was drawing rectangles around the double integrals. this just works for me. Okay, 2 more problems. Yes, no 3. Okay, you're okay. All right, and this looks like a word problem, but it's not. They just give you this cost function. They give you a cost function. It's 3,800 plus 7x plus this y plus this x plus, okay, 3,800 plus 7x plus 8.8y plus 0.01 x squared plus 6xy plus 0.05y squared, okay? And while you write this down, I'm going to write it down again so I can mark it up when I take the derivative with respect to y. And yes, they ask every function has 2 first derivatives. 6xy plus 0.05y squared. But there are also second derivatives, and there are 4 second derivatives, and so we cut those out. We figured if you could take a first derivative, you could take a second derivative. So there. So you don't have to do that. So let's go take the derivative of this cost function. They want the marginal cost with respect to x. So with respect to x means I'm going to go do this. I'm going to identify my x terms. And those are my variable terms. And so everything else is constant. Okay, so I'm just taking the derivative of 7x with respect to x is 7 plus the derivative of 0.01 x squared with respect to x. I multiply down and subtract 1 plus the derivative of 6xy with respect to x, all right, is just what? 6y times the derivative of x, which is 1, okay? All right, and I'm very ashamed that I wrote too big, and I had to go down here. But the derivative with respect to y, and this is my cost function. This is the notation they were using. Okay, so I'm going to go identify my y terms. So if I take the derivative with respect to y, my x's are constant, and those derivatives are 0. So I'm just taking the derivative of 8.8y, which is 8.8. And the derivative of my x term is 0 plus 6xy. The derivative of y is the constant in front plus the derivative of a y term with respect to y is just normal, 0.10y. Okay, so those are my derivatives. Okay. Alrighty. I feel like I'm on the late night show. Okay. So this was a wordy type problem. It says this a production company sells 2 types of car radios, I think they were. A standard model for 110, a deluxe model for 240, and they give you this cost function, okay, where X is standard and Y is deluxe, okay, and they want the marginal profit with respect to X and the marginal profit with respect to Y, okay. All right, so if I want to take the derivative of profit, I've got to have a profit function, okay. So the first thing I'm going to do is write my profit function, and we know what profit is. What is it? The profit function is what? The revenue function minus the cost function, right? We know that. Profit is revenue minus cost. Okay, all right, so they've given me my cost function, but they haven't given me my revenue function. X is standard, and then deluxe is Y, okay? So what is my revenue function? Okay, my revenue function is what? how much do you make? Well, you make 110 for each standard plus 240 for each deluxe, right? So we'll go rewrite that. But my revenue is R of XY is 110 for each regular plus 240 for each deluxe. Okay, so I'm going to take that, I'm going to subtract my cost function, I'm going to distribute my negatives and stuff like that, and then I'm going to take the derivative. Okay, all right, so you ready? Am I moving too fast? I'll do it here. Let me go sideways. Okay, so my profit function is my revenue, so it's 110x plus 240y minus my cost function. And they give me my cost function. Plus 0.2y squared plus 0.325xy. Y'all, I swear to you, that's my dog snoring in the background. I don't know if you can hear it. So profit is revenue minus cost. And we had to write the revenue function. Does everybody see how we got the revenue function? Because it said, how much do you make? Revenue means how much do you make? Well, you make, and they said X is the standard and Y is the deluxe. So you make 110 for every standard plus 240 for every deluxe. So that's my revenue, okay? And then so now I do revenue minus cost. So my profit function is 110x plus 240y minus 65,000 minus 0.4x squared minus 0.02 y squared minus 0.325xy. And I don't think I have any like terms, okay? So they want to know the derivative of profit with respect to x. So there's an x, there's an x, and there's an x. So the derivative of the profit with respect to x is what? 110, that's 0. Derivative of a y term is 0. Derivative of a constant term is 0. So minus 0.8x. And then here I have an xy term. So it's the derivative of the x term. Well, derivative of x is 1 times the constant in front of it, which is just 0.325y. Okay. And then let me write my profit function again so that I can go mark it up. That's what I got after I subtracted everything. So the marginal profit with respect to y of xy, I'm going to go mark up my y terms. Okay. All right, so the derivative of the x term is 0, so it's 240. The derivative is 0 of an x term, of a constant term, minus 0.4y minus, and the derivative of the y term is just a constant in front of it, 325x. Okay, so that is the word type problem. I have one last problem. It's not a word problem. Instead of having X's and Y's, it has S's and T's, which I despise because my T's look like pluses and my S's look like 5s, but I can do it. So I don't know if they say the derivative of f with respect to s, or if they say the derivative with respect to s. I'm not sure. But the first one is s. So I'm going to go there. Here's an s term, and that's it. So this is constant. This is constant. So the derivative of an s term with just s's in it is normal 3s squared, plus the derivative of a s times t term is what? It's the constant term, 17t cubed times 2s. Okay, so I'll write my function down again, just because I've marked it up. Uh-oh. I had an S here. I thought it was a 5, see? All right, so the derivative of the s term, right, is just 1 times the constant plus t to the 4th. Sorry, I forgot that. All right, so the derivative of a lone s term is just the power rule, 6, the derivative of s times t. Remember, I just take the derivative of the s term, so it's 17t cubed times the derivative of s squared, which is 2s. And this is the derivative of the s term, which is 1, times the t term, which is just t to the 4th. Okay, and then the derivative of f with respect to t, or f of t. I'm not sure how they asked this. I didn't write it down, but it's the last question. So let's go. Here's my t's and here's my t's, right? So the derivative of s cubed is 0, okay? So the derivative of 17s squared times t cubed is 17s squared times the derivative of the t term plus s times 4t cubed. And that's just how I do it. The derivative of negative 13 is 0 in either case. So that was my derivative with respect to s. And this is my derivative with respect to t. And that's the end of my video lectures. Email me if you have questions. No go and my name. All right. So I hope it helps, and I hope I talk to y'all soon. All right. So don't forget, when you take a test, you have to upload your work to Blackboard. Go to Blackboard. Everything's on Blackboard. I've moved everything up. Just go to Blackboard and it'll show you how to do it. You take a picture on your phone and upload it to Blackboard. You have to have the mobile app for Blackboard. You can do it from your computer, but y'all know how to do it. Okay. All right. Best of luck to you, and I'll talk to you soon.